Since we first took to the skies, pilots have faced bad weather, and sadly not all of them have come through unscathed. So in this program we'll look at how to deal with the problem. We'll talk to professionals from around Australia, including chief flying instructors, meteorologists and investigators. You'll learn why pilots should plan thoroughly and make timely decisions. So what happens when a pilot enters cloud? According to aviation medical expert Dr. David Newman, it doesn't take much to lose your bearings.
Well, normally we orientate ourselves in space by reference to the horizon, a visible horizon, and the force of gravity, which is 1g on the surface of the Earth. Now, when you go flying, of course, you can get into a situation where the horizon is not clearly visible, and of course, if you manoeuvre the aeroplane, you can get more than 1g. So we can alter our natural references very easily in the aviation environment. Now, if you lose visual reference outside the aircraft, then 80% of your orientation information has gone. Visually based cues are responsible for most of our orientation information. Now, the remaining 20% is split equally between the inner ear balance mechanisms and what we call the seat of the pants, the proprioceptive system. So those two systems alone without visual cues are not that accurate, and it's quite easy in IMC conditions to become disorientated.
Why would anyone fly into cloud? The ATSB has released a report about pilot behaviour in the face of adverse weather. Let's hear about it.
As we describe in the report, basically weather-related decision making isn't a one-off static decision, it's really a dynamic ongoing process. And what I mean by that is that during a flight, a pilot will have to continually make a series of related decisions about the weather. And they might make 4 or 5 good decisions in a row. They might initially take off and then turn back. Then later they might try a second time, they might go part of the way, they might divert. But again, at each point, the flight is only safe as that last decision that the pilot makes. So in a way, you'd like to think that you get a bit of credit. You made 5 good decisions, you get a bit of credit, and you're not judged so harshly on the next decision. But unfortunately, it doesn't work like that, does it? So it's that idea of always being continually mindful of the situations, looking and planning ahead, and continuing to make good decisions.
As you can see, good decisions are essential, but they must begin at the planning stage. Proper flight planning reduces pilot stress and increases safety margins.
I think it's very important that before a flight commences, and probably even before the planning commences for a flight, that the interested parties, if you like, should sit down and discuss what the no-go situations are.
Best advice is do your preparation. Collect all your Met data, look at the Bureau of Met site, through NAPE, submit your flight plan your trip as carefully as you can, doing as much homework as you can, planning by the safest route and not the most direct route.
Using things like the Bureau of Meteorology website, Air Services Australia, local knowledge by calling people along the route.
A lot of aerodromes now have automated systems whereby they're actually giving you reports. Study the reports, talk to someone at your destination, maybe the CFO of the flying school.
Do you know how to interpret a TAF? The Bureau of Meteorology website has a fantastic e-learning section. There's a weather decoder for all your TAFs and METARs.
All of the products that we send out, which includes the observations, warnings, forecasts, and forecasts include the area forecasts for general flying, the TAFs, so for landing and taking off, those sorts of things, as well as airport warnings, SIG weather charts, anything you could possibly need for planning and preparing for a flight can be found on the Bureau's website.
Weather does change. There seems to be, and it's not just in aviation, it's in all areas. We often get people that get the forecast for next weekend on Monday and assume that it's going to be the same. The weather does change, and it can change quite rapidly. So most of the products that we do are issued routinely every 6 hours to take account of that change, and of course updated in between those 6 hours if necessary.
It's also good for pilots to keep a good weather outlook for what's happening. I know a lot of pilots generally don't fly every day of the week, but it's always a good policy to tune into the evening weather services on the television stations. Gives you where you get a satellite image and the surface weather chart, and with time looking at those and looking at the weather, what's happening the next day, you'll build up a feel for what weather situations create what conditions, and what situations in particular create conditions where visual flight rules do not apply.
There's only so much information we can put into a TAF or an area forecast. If pilots are a little bit uncertain about conditions or want a specific wind forecast for a certain flight, or just really want to know a little bit more information or any uncertainties that might appear in the forecast, they are more than welcome to ring the forecaster directly.
You've covered all your bases. Your planning's included weather, fuel, alternates and safe altitudes. You've briefed the passengers and decide to go. Once airborne though, you have to remain vigilant and be prepared to make decisions early.
When you come to the conclusion that the weather is not as good as you thought it was and that you're not going to be able to get through, then now is the time to make a decision, and the decision is best made early. It's no good leaving it to the last possible moment and saying, oh, I'm going to keep on pressing on and maybe I'll get there, maybe I will, and then in the end you find you're in cloud, and then that's not a happy place to be if you're a VFR pilot.
A great decision-making tool to have as a day VFR pilot is to have considered your lowest safe altitude for the route that you're about to take. I suggest that you just run along 10 nautical miles either side of your track and add on 500 feet to the highest terrain. This becomes your lowest safe altitude. In flight, if you're not going to be able to continue seeing the horizon at this altitude, that's the point at which you need to make a decision of either diverting or returning back to base.
Safest group, that's the pilots that took some sort of proactive weather avoidance action, took that action in the first half of the flight. In actual fact, often took it quite near their point of departure, so they might have taken off and then realised that the weather wasn't perhaps as good as it was forecast, or that they were heading towards adverse weather, and so they've made a decision perhaps to return to the aerodrome that they departed from. And in contrast, the VFR into IMC group, those occurrences occurred far later in the second half of the flight and often quite near the destination. Pressure for pilots as they get close to their destination to sort of press on and think, look, I'm almost there, if I just keep going I can probably get through. Whereas in that case they're probably better, if things really have deteriorated to quite an extent, to carry out a precautionary landing.
Above all, it is not closing the back door, not closing a side door, and if little voices inside you are telling that it's not a good situation, then when in doubt, turn about. It's the push-on-itis that will end up putting you into jeopardy.
Making the decision early is the important thing. Most of these things occur because we don't make a hard decision. We don't make the decision to turn and land at an airfield that's in the clear simply because it's not the destination. We always want to get back. It's where our family is, or it's where our car is. It's the familiar place. Whereas if you have to make the decision to go to another airfield, there's all these complications when you get on the ground as to how do I get the aeroplane back, where will I stay, etc. But they're sort of complications that are easy to fix on the ground.
Is VFR pilots tend to push on. 5Ks is a very little distance, and a good judge is if you're sitting in the aeroplane, flying the aeroplane, and you're actually having to look out the window on the side to see where you are instead of looking forward, and the forward visibility you got is no longer any good, and you should consider turning around or diverting to where there's better weather.
A lot of the time people get into cloud when they didn't mean to is they didn't make a decision and all of a sudden they're in it. Again, we need to give them practice in this defensive idea that could I get through there? What could go wrong? Have I got an escape route? It's okay to turn around, it's okay to consider that I won't make my destination.
If it's a VFR pilot who's trying to fly somewhere and there's a deteriorating weather situation in front of them, that's going to concentrate their attention to an extent. As they approach the bad weather or even enter the bad weather, they're likely to experience a stress reaction to this event. Heart rate will go up, their blood pressure is going to increase, they'll start to sweat, they'll start to become quite concerned about their situation. Now this can affect their decision-making process. As their stress reaction goes up, their ability to make a clear, rational decision may become impaired. At that point it's quite dangerous because the pilot may not make a clear, accurate decision to turn around and go back out of the bad weather.
You're in the air, but you have some concern about whether you can remain visual. It's simple. Talk to air traffic control, and if you get into cloud, they can be a lifeline.
On average, around once every 10 days, a pilot declares an emergency. And that equates to around about 60% of them are basically on top of cloud, where they can't get down through it, and the rest are basically through either in cloud or reduced visibility through things like smoke and fog and things like that. Luckily for us, most of them get away with it with the help of air traffic control, and these are also only the reported occurrences as well.
The best emergency is the one that doesn't occur, and if there's any doubt or whatever, ask for assistance. We're there to help, and if we can, we will, and we'd rather prevent it becoming a full-blown emergency than actually have a full-blown emergency.
Air services and the military, we operate off the same document, so we do air traffic control the same way. So from a pilot's point of view, it should be seamless. So whether or not you're flying into a military-controlled aerodrome or a civilly controlled aerodrome, the procedures are exactly the same.
The first thing to do, the controller will try and ensure that the pilot's flying the aeroplane, like if it's in cloud, monitoring instruments, etc., and we'll try and ascertain from the pilot how much instrument flying time they've had, look at things like if the airplane's got an autopilot and whether the pilot's able to use it to help assist flying the aeroplane. That's the first thing we need to sort out. Then we'll use other pilot or other aircraft around the place, Bureau of Met and other information that we can get hold of to try and find out where other VMC conditions are, such as if you're on top looking for holes in the cloud base. If they're in IMC, it will be looking at sort of where that we could navigate the aircraft to. We may ask the pilot questions as well about when was the last time he was in VMC, etc., because it may be the closest place is actually to go back on, sort of do a reciprocal track to where they were. So the first point is to try and ascertain the situation, and then we'll use all variety of different sources to obtain or work out where the best place is to help the aircraft get to.
If you happen to find yourself in trouble or looking at diminishing options when it comes to weather, please don't hesitate to call. There are all sorts of air traffic services out there. You don't have to be in a controlled environment like a military aerodrome. You can be OCTA and still be able to get Flight Watch and other control agencies on HF and VHF. They're all there to help, and yeah, you're not alone out there, so make sure you speak up if you're likely to get into trouble.
Once you're in cloud, things can quickly go wrong. It could help if you have instrument experience, but remember, it takes instrument-rated pilots more than 40 hours to become proficient, so it will take you more than a little luck to survive.
First thing you got to do is stay calm, stay on your instruments. Your instruments won't lie to you. Stay on the artificial horizon, maintain wings level. Then get on the radio and ask for help through the relevant ATC section. If you have someone beside you, get them to help you as well. Use air traffic control as basically your co-pilot where necessary.
A pilot entering IMC may go into a turn that they don't recognise, and this can occur for many reasons. One wing may drop some degrees, the pilot may be preoccupied in the cockpit with trying to work out what's going on, may not recognise that the wing's dropped and it's gone into a turn. Now the balance mechanisms in the inner ear have a threshold below which they won't pick up any motion. Now that can occur when a pilot goes into this one wing low type situation. If the pilot then recognises that they're in a turn and recovers, that recovery is likely to be quite quick, and the inner ear mechanisms will then get some input that they're turning, and that can create a mismatch between what the pilot feels in their balance system compared with what the instruments of the aircraft are telling them. Now that inner ear mechanism can give very strong impulses to a pilot. to the extent that in some cases the instruments will be ignored and the pilot will simply follow what their head is telling them. Now that can clearly result in a significant spatial disorientation event. Now pilots need to look at the instruments and make the instruments read correct, straight and level, and try to ignore the sensations that their head is giving them. That can be very difficult because the sensations can be very strong, but clearly it's important to believe the instruments rather than what the pilot's head is telling them. Other factors can make disorientation more likely. What the pilot's been doing in the 1 or 2 days prior to flight can have an important effect on the risk of disorientation. Alcohol can make disorientation more likely. Even the hangover effect can make it more likely. That's also going to interfere with the pilot's decision-making abilities and overall flight performance. Any medications the pilot may be taking for whatever reason can interfere with their inner-ear balance mechanisms, the decision-making process, and of course the reason they're taking the medication. If it's an illness for whatever reason, so even a simple one like a cold or some respiratory tract infection can impair not only their overall flight performance but their risk of disorientation.
One of the big things that pilots don't do is they don't slow their aeroplane down. That is very important. When you get into bad weather, the cloud base is lowering, the visibility is decreasing, put the aeroplane in the precautionary mode. Every aeroplane has a precautionary mode, usually a couple of stages of flap, slower speed, and this gives you time to think. This also decreases your radius of turn when you turn the aircraft. So slow the aeroplane down. Get away from the cloud, slow the aeroplane down.
Basically, sub-regulation 4 of Regulation 157 gives you an out for not being permitted to fly below 500 feet or 1,000 feet over towns. And that is that it says, through stress of weather, you may descend to a lower altitude if it's essential for the safety of the aircraft. And essential means that there's really no other safety option available to you. In other words, if you don't do this, then there's great risk to the aeroplane and to yourself.
Most people learn to fly in blue skies, but it's worth experiencing bad weather. So go on a flight with an instructor and experience marginal conditions. This will help you in the future to make decisions that could save your life.
The best thing we can do is, we try to encourage people to continue their training. Most of them, once they have their basic ready, they do an aerobatics rating afterwards or a night rating. And by that time, maybe the weather will change a little bit and things like that. Or we encourage people to come back and maybe do a backseat with somebody when the weather is a bit different as well, so they get the real exposure to the weather, really,
But I think the biggest thing we can do is give people practical experience of what it's like, so they can see it coming for themselves, and rather than it being a theoretical, abstract thing that they've talked about and read about, but it will never really happen to them, they are put in the situation and realise what it's like, and will either then decide themselves that it could happen to them and they'll get instrument rated, or at least they've been put in the situation with an instructor and they'll see it coming and hopefully be prepared next time to turn around before it's too late.
So there you have it. If you're unsure about whether to fly, don't go. But if you're well prepared and proactive, you'll have less stress and greater safety.